This one is a perfect example of something that you would want to do rationalizing with. Now, notice that it's one expression on the bottom, so it's attached by a plus or a minus sign. It doesn't have two different denominators with two different expressions that you're adding, so there's nothing over here beside it that you're adding or subtracting with. It doesn't have different things that you could factor or something like that. So this is one that's set up that way. And with regular square roots, the way that I rationalize is I multiply both the top and the bottom by the square root to make the radical go away. In algebra, the way that you make something go away like that is you're trying to get it so that the middle terms cancel out when you multiply by something. So what you end up having to do is you have to multiply both the top and the bottom. Remember, if we multiply the top and the bottom by the same number, we haven't changed anything. It's just like multiplying by 1. In order to do that in algebra, you multiply by the opposite of whatever this sign is. So what we would do is we would multiply both the top and the bottom by 1 minus cosine of t. And what happens on the bottom then when we do our multiplication is we get 1 times 1 is 1. 1 times minus cosine is minus cosine. And cosine times positive 1 is plus cosine. So what happens is the middle terms cancel out. You don't have a middle term. And then when you do plus cosine times minus cosine, you get minus cosine squared. And so then when we look at our identities, we can see that sine squared plus cosine squared is equal to 1. And usually this is going to help us because it's going to be equal to some sort of identity. And when I bring the cosine over, I get 1 minus cosine squared, which is what I have. And 1 minus cosine squared is equal to sine squared. So now on the bottom, I have sine squared. On the top, I have 1 times 1 is 1. 1 times minus cosine is minus cosine. Minus cosine squared times 1 is minus cosine squared. And minus cosine squared times minus cosine is plus cosine cubed. Now, a lot of times when we do this on the top, you'll be able to combine like terms. But notice we have a cosine to the first power, a cosine to the second power, and a cosine to the third power. You can't combine those as like terms because they're raised to different powers. So what we would need to do, we would need to try to factor that by grouping. And if you'll pay attention to the previous video, you can see the factoring by grouping. So what I'm going to do is I'm going to clear this slide and write down what we have so that you can see it again. So we have 1 minus cosine squared plus cosine cubed, and that's all on the top. And on the bottom, we said we had sine squared. Okay, so if I factor this by grouping, and the reason that I know to try factoring by grouping is because it has 4 terms, and that's your clue that it should be something that you can do by grouping. And with grouping, you group the first 2 and you group the second 2 and you try to pull out a common term. So when I group this first one, there is no common term between 1 and minus cosine, so I'm just going to pull out a 1 as a placeholder. And then I'm going to drop down this sign, and I'm going to pull out whatever's in common between cosine squared and cosine cubed. And when you do this, you take the smaller one, and I say, okay, if I have pulled out a minus cosine and I'm pulling it out of minus cosine, I have a 1 left. And if I'm pulling a minus cosine squared out of a plus cosine cubed, I have a minus cosine left because there were 3 and I pulled out 2. That leaves me with 1. Now look at what's happened. The thing in parentheses is the same, so it's now my common term, and I'm going to pull it out. And what I have left over is 1 minus cosine squared. And on the bottom, I still have sine squared. Now, we just got through saying that 1 minus cosine squared is equivalent to sine squared. So I can cancel these two out as a common term because they're the same. And I am left with 1 minus cosine. And that is as far as I can go with that because 1 minus cosine is not one of my identities. 1 minus cosine squared is an identity, but not 1 minus cosine. So that's as far as that one will go.